Hello and welcome to my tutorial to TrackMania Unlimiter 2.0. Today we are going to talk about dynamic blocks and how we can add them to your track. Dynamic blocks are just moving blocks throughout the run. They can be shifted and rotated in an axis. What is interesting, we can apply movement to special blocks like boosters or checkpoints, but keep in mind that respawn position will stay at the original position of the block. What is also important is dynamic blocks cannot be scaled, so keep it in mind when designing your track. We have two ways to create a dynamic block. Upon enabling this option, we can do it media tracker style, just add some keyframes, set the values and see as the blocks move through them. If you want more control, you will need a script. Now, you can control the block's position, rotation, visibility, and collisions through code. Marking the block is required even if you just want to make block appear or disappear without movement. There are no ready movement procedure, so all operations have to be applied frame by frame manually. Before we jump into an editor, let's quickly talk about the server synchronization. It is a setting that can be applied to a map. With disabled server synchronization, movement phase is controlled by the client. Every run is deterministic. With each restart, block phase is being restored. It behaves similarly to random boosters. If you want to make sure platforms are synchronized for everyone, we can enable server synchronization. Keep in mind that in time attack mode, it can lead to cheated runs by optimizing start time. Alright, that's enough intro. Let's see the dynamic blocks in action. Hello and welcome back. Let's add some dynamic blocks. So in this example we have this gap here. We want to make block move from one side to another. Let's add some. So first we need to select the block that we want us to move. Let's add this one. We can place it and as you see nothing happens. We need to click this icon and enable is dynamic. We see this time frame. We need to add the keyframes. This is going to be the start keyframe. Let's move our timeline. Let's add the second keyframe. And the standard size of the block on stadium environment is 32 units. So let's move it 32 units. We can hit play and see how it moves. It's kind of too fast. Let's move this time frame for 3 seconds. Oh, it's way better. We can show the full time frame. Let's play it again. Also, we can change the interpolation as we want it to go back and forth. Let's try the triangle interpolation. And here we have it. We can place it, for instance, here. Okay, let's test it. As you can see, the block is here. Oh, it's going to be difficult to time this correctly. Let's try it again. As you can see, there is a lot of experimentation that needs to be done. But now we can, for instance, try to change it to sine and maybe extend it a little bit. We hit play, so we can see it moves a little smoother and a little bit slower. So let's try this one. Oh yes, let's wait for this block to come. Awesome. Let's quickly talk about interpolation. It is the way the game moves a block between two keyframes. On the screen you can see two scenarios. First is simply from point A on the left to point B on the right. Second goes from left to all the right and then ends in the middle. As you can see, the sawtooth is one-way street. Once the animation ends, block resets to the starting position. Inverse sawtooth is useful if you want to replicate the same move backwards. Their movement is at fixed speed between the keyframes. Sine and triangle interpolations are twice as fast because they move forward and then return. Sine wave starts more gentle and gains speed throughout movement. Triangle has a fixed speed, similar to sawtooth interpolations. Lastly, A square interpolation, it swaps between the first and last position. Middle keyframes do nothing. Alright, as we have the platform moving, let's add something another. We want to attach this pole and rotate it along this axis. We cannot scale the thing, but still we can rotate. So we're going to bend it like 90 degrees like this. We're going to mark dynamic. We're going to add the start keyframe, the end keyframe, and set the rotation to 360 degrees. Let's hit play. Oh, it's way too fast. Let's scale it down to 5 seconds. Okay, that's more like it. But as you can see, the block does not rotate correctly. It's because its origin is in the corner of the block. It will require experimentation, but we should change the origin to 16 and minus 16. So now we have it rotating pretty neatly. Now, the only thing that we need to do is probably to move it a little bit here, and we can attach it to this pole. Bam! Let's see it in action. Alright, awesome. Okay, let's see how we can edit block properties through scripts. Here is a small procedure that will trigger at the start of the race. For more on scripts, please check other tutorials from this series. To get to the block state, we need to get challenge from the race object, then get blocks from the challenge object, then find the correct block, and at the end we can get block state. Then we can set position, rotation, or flux, which is basically is visible or is codable properties. The idea of the program is to pick random number from 1 to 3, and based on that, unlock one of the gate by setting the flux of enable. Let's see in action. Now, let's add the gates. First, load the script. Then we need to create a block group, because the script uses the block group. It was called doors. Also mark automatically add to a new block. Close the prompt. The last thing we need to do, we need to enable is dynamic and also manual control for the block. Now we are ready to put the gates. Let's test it. Every time we will restart, one of the gates is opened. Let's check if it can collide with this one, and if we can pass through this one. Okay, everything is working. That's it. Thank you so much for watching.